about the two distinct divisions of statistics. So we talked about descriptive statistics. It entails the use of descriptive aids, such as line, chart, bars, and summary statistics to present information. Though we said it simply that it entails organizing, summarizing, and describing of data. Now, the inferential statistics, it entails the drawing of inferences or conclusion about a given phenomenon using summary statistics from the descriptive statistics. And that means inferential statistics entails you trying to generalize. You want to infer. I always use a very funny example. I'll tell you, for example, you go to an health facility and the person complains or probably says he's not feeling well, I'm feeling cold, I'm feeling tired. And the doctor says, okay, go and run the test. So the person goes to the lab, and then they take a very small portion of blood from the fingertip, and then they run the test. So after the test, they come out and say, look, mister, I haven't run the test. We observed that you have typhoid and malaria. And the person said, no, I can't have typhoid and malaria. I said, why did you say so? He said, well, it's because you have collected blood from the tip of my finger. Collect blood from the tip of my toe. I'm sure when you run the test, it will show a different result. So what do you say to such a person? Say you don't know what you're saying. Now, you might be amazed that by just taking a small portion of blood from the tip of the finger, you can say something about the whole body. That's what we call inferential statistics. Trying to draw inference about the whole using information from a small portion. And that's what statistics is about. You try to say something about a large pool of data, extracting just a small information from a part. However, to draw this inference, several tools are required. Some of the tools we use in drawing inference are correlational tools, hypothesis, estimation tools. So these are tools for drawing inferences. These tools, will see them as time goes on. Right? Having said that, choosing appropriate statistical tool. How do we know the tool that is appropriate for the given research? To do that, we need to ask ourselves questions that are fundamental. For example, we ask ourselves, what's the general purpose of the research? What are the specific purposes? Just like we said yesterday, that you should have what we call the aim and the objective. So the general purpose is the aim overall. So is the general purpose out to explore relationship between variables? Alright? If the aim is to explore relationship between variables, then you want to ask yourself, is it aimed at making comparison between groups? To know that from the general purpose objective, at that point you might just need to describe. But when you now break it to specific, because in trying to break down the objective to specific, you're not trying to break down the independent variable into several components. So you're asking yourself, is my aim to compare the groups? Is my aim to find the strength of association between the variables? Because in the specific objective, you would have been able to extract several other variables. For example, if your work is to look at perception about service delivery, effect of a service delivery on customer satisfaction. Customer satisfaction is a very broad concept. It's what we call the 7-qual model. You've heard of that model before. A model that wants to look at service quality, empathy, wants to look at in terms of service rendered. We'll look at that later. These are models for measuring service quality. Okay, we'll look at it when we go. But I'll give you that model. A very good model. It has a theoretical on that too. We'll look at it when we go. I'll show you. So that model, the SERVEQL, that thing is called service quality. So each of the S has a